Hello, and thank you for joining the Blueberry Educational Conference as part of the 2021 Virtual Southeast Regional Fruit and Vegetable Conference. We're sorry for the technical difficulties. You know how technology can be. I'm Zach Williams. I'm the Bacon County Ag and Natural Resources Agent with the University of Georgia Extension, and I'll be the moderator for this presentation. I'd like to thank Meister Media for sponsoring the 2021 Blueberry Educational Conference. And just like the other presentations for the Pesticide CEU and CCA credits, if you'll put your first name, last name, and the state for which you're requesting credits in the audience chat. Also, whenever before the presentation ends, make sure that you put your first name, last name, and the states for which you're requesting credits to sign out so we can get the CCA and CEU credits. Also, you have to do that for each presentation, but this one with the third step in getting the CEU registration credits is you only have to complete this registration one time under the Pesticide CEU registration. It's not required. To access that, you go to the Pesticide CEU registration web link, open the Pesticide CEU guide on the Event Resources tab located under the media player. The Pesticide CEU registration web link is located on the front cover of the guide. At the end, we'll have a question and answer. You feel free to type in a question at any time in the audience chat box. And without further ado, we have Dr. Jason Schmidt with the University of Georgia Entomology Department to give us some updates and ideas on conservation practice with the pollinators. Jason.
All right, thank you. Here I am, and we'll see if we can get this rolling. I'm assuming my slides are visible now. Yes. Well, when I was preparing for this presentation, I was hoping to do a Google search and find a few things. But what I found was some of the top searches were for last year, according to Google, were why can't I sleep? Another one was, why are parasites so good? But what I was hoping for was that there were so many people out there wondering about why should I care about biodiversity. And I'm going to talk a little bit about that today. And as a reminder, I'm Jason Schmidt, Associate Professor of Entomology, University of Georgia in Tifton. And I just have three things that I'm going to talk a bit about today. One of them is this idea of biodiversity. I'm going to mention a bit about some of the threats and also the importance. I'm going to talk specifically about predators and parasitoids in Georgia blueberry landscapes from some of the research we've done over the last few years. And then I'm going to talk about a project that's just beginning, and we're excited about it. And it's something that's growing across the world right now, and that is finding ways to optimize habitat management for enhancing diversity that will provide services for our agricultural systems, and in this case, specifically for blueberries. So there's a real active conversation right now about some axes of important sustainability measures in our agricultural production. And one of them, according to a number of papers, is loss of biodiversity. And another key one is how the climate is becoming quite a bit variable and makes it more difficult to predict when we are going to be successful and not successful at adequately producing economically sustainable yields. And those two components are key for sustainable production. One of the ways from kind of a local to global strategy to change this is we definitely need to know what biodiversity is out there and what it's doing. And then building technologies that can help enhance or conserve the key ecosystem services such as pollination and biological control that are already in our systems, and then find ways to make those even better than what they are. So, many of our farmlands, though, right now, if we look at the landscapes, this is just a little picture of Georgia. And you can see that all these little areas here from a very broad scope, these all areas are, aside from the darker green areas, are areas where we're producing agriculture, which is in demand right now because we need food to feed this very large growing population. However, that leaves very little area, that dark green, for kind of the natural services needed to also help sustain production. So if we blow that up, and this may be a little bit difficult to see, but if we blow that up, we can see the different types of production that are in these landscapes. And this one, I've highlighted a few different key features in Georgia. One thing that we work with is we have to work our agriculture around wetlands. So all this light aqua blue here, all wetlands, and obviously you can't grow crops right in those wetlands. So we have to embed our crops around those. And you can see that growers have done a very good job working in agriculture around those areas. And there's some very dominant agricultural features there, such as this yellow, which are all row crops. And then you can also see blueberries nested within this landscape of different types of crops. But a lot of that area is still mostly crop production and maximizing the use of the land, meaning that there isn't really much left to convert to more agriculture. And if we look at some of the key things then that are linked to preserving and conserving biodiversity, one thing that globally has been identified is finding ways to maintain habitat loss or habitat change, identified here, and a few other ones. Were linked to the numbers or abundance of different key arthropod groups, be beetles, we have wasps, we have caterpillars. So different types of biodiversity, arthropod biodiversity in landscape. And habitat change is one of them because it alters where organisms can live. And so finding ways to conserve that habitat is likely a way forward for maintaining biodiversity. So, so like I said, the first piece then to doing some of that conservation is understanding our biodiversity. So I'm going to share a little bit about that with you. And then the second one is, how do we go about enhancing? Where do we enhance? Where do we conserve? And where are the opportunities out there that aren't going to impede on our ability to produce high amounts of crops and be profitable? And those are key. Those axes of sustainability, I think, are very important. We can't just have biodiversity and not have good economic crop production. So they need to go hand in hand. So is biodiversity important? And I'm going to argue yes. I think one of our loss of biodiversity and the functions associated with it is probably one of the 21st century economic or kind of crises, because this biodiversity is doing all kinds of things for us in terms of moving nutrients around in the soil, breaking down components in the soil, pollinating our crops, and also controlling pests within the landscapes. So biodiversity is key for that. And global synthesis also shows us that when we have greater numbers of species, so in each one of these graphs here, when we have greater numbers of pollinator species in an area, or greater numbers of natural enemies, being those that are natural pest managers of pests, we get greater amount of pest control. So those have to be tied if biodiversity is going to be important. And secondly, if we take those then and say, okay, well, that's great. We may have this greater richness, and some of us really like that, but is it really doing anything for production? And it is. From global synthesis, when we have greater amounts of pollinator species, we get a positive correlation with production, and also with what we get is the output, our production output. So, and that's true also for biological control. So when we have greater species of parasitoids, predators, and these sorts of species within our system, we get greater pest control services, which also comes out as a positive in terms of production. So finding ways to promote biodiversity is important. So should we care about it? I think we should. So knowing some of our functions out there, I talked a few years ago about the predators, and that and in that presentation, I talked mainly about predators of spot-winged Drosophila. It's definitely a key pest. But we found that the generalist predators that we found out there were contributing pretty little to SWD control or SWD predation. And so I also showed some things about how the predator community out there, though, is eating lots of different other things and is quite diverse. So that is good. And I'm just going to mention them a little bit again today, but then I'm going to focus a little bit more on these parasitoids briefly, and then lead into the next piece. So how do we go about studying predators and parasitoids out in these landscapes? Well, for this study, what we chose to do was characterize this in a number of different ways. First, we found the main primary systems out in Georgia landscapes of blueberries. So organic, conventional type, which is characterized by different use of pesticides, fertilization, and also herbicide use. And then we found those working with hand in hand with growers, and then we've sampled them at 3 different locations within those orchards to have an idea of the spatial distribution of predators and parasitoids. So I'm going to share a little bit of that with you again as a reminder. So we got a lot of predators over all of those samples. This was a 2-year study. And then we also got some parasitoids, and these are really small. They're quite difficult to identify. So I used a DNA approach to get their DNA sequences to identify those parasitoids. So I'll share that. In terms of the predators, if you look at this, if you recall the game Pac-Man once upon a time ago, if you look at this big Pac-Man part here, all of this area is broken up into different families of spiders. So most of the predators that we collected out in these blueberry systems were primarily spiders and different spider families. This one here is a web building, so web building spiders we found, and then also jumping spiders. If you have seen those out there, jumping spiders were the primary. And then we also had parasitoids, which I'm going to talk about, and then a few different insect taxa. For the parasitoids, we had a very diverse group of parasitoids. So there was at least 12 different families of parasitoids and 33 different genera. So while their numbers are low, we do have diversity. So that's good. But a goal would definitely be to build some of that diversity. I'm going to just share a few of what these look like. And again, I mentioned that these are very small. I created some little diagrams here to give an idea of how small these can be. So even below 1 millimeter up to 5 millimeters, and some of them, like these ichneumonids, can be quite big, even a few inches long when you consider their ovipositor. And these parasitoids from these diverse groups actually parasitize quite a few different groups out there that would be important for blueberry and also for other pests in the landscape. Notably, this group here was quite common, and this is a parasitoid of that sharpshooter that is talked about occasionally. And a number of them also parasitize Lepidoptera pests, and there's some aphids and some other forest species as well. So there are parasitoids out there, but there weren't very many from our samples, but we're planning to follow up on this in future years. Looks like I'm on alert. Okay. So we did have diversity, but we had quite low numbers of them. For those following the SWD literature, SWD parasitoids, there's the regulations have made it through the USDA, and so releases are going to be made. So stay tuned on that. And I think Ash Salih and his graduate student are going to be working with that, and I'll be collaborating with them on that, I think. So stay tuned on that. So what about planning for habitat? I mentioned that habitat is important for maintaining predators out there, and I didn't talk about pollinators, but it would be pollinators as well, and also these parasitoids. So what are some ideas currently about doing that? Well, the NRCS talks a bit about some of these opportunities. One of them is by this picture here. So I mentioned before that in Georgia and in other areas, there's many waterways, and planning initially to have at least a 35-foot buffer from any waterway is a great opportunity for habitat enhancement. So they call these riparian buffers because they're usually wetland type plants until you get to this upper area. Multiple benefits from that, not only from pest management and pollination, but also erosion. Another one is planning for diversity in between rows and potentially even within in between rows of blueberries or other crops. And this has been done in a number of systems, including almonds, some of the pecans, some apples, even viviculture. And so it's a growing area for providing native flowering plants that can sustain those agricultural environments to promote pollination during key times of the year, and also for natural enemies. Another one that's key for making that work is to select species that will thrive within these different environments. So my group has set up a number of these. If you look out here, it's a very small picture, I realize. If we were actually in Savannah, it would be so huge and easy to see, but it's a very small picture. And these are little monoplots of different flowering species. And one key thing there is they don't all grow in the same height, the same width, and they also don't all thrive in certain soil conditions, as you might guess from just growing crops as well. So we're trying to calibrate which ones are going to grow good in different environments, and then which species they attract that would be key and economically important. So we've started some work and that has just begun this year and will continue. We're working with 4 growers across Georgia to implement some demonstration plots in collaboration with the USDA and Woodward & Curran on habitat concepts for blueberries. So stay tuned, contact Zach and I if you have any questions on that, or if you want to participate later on, and hopefully you'll attend some of the events we have. And in closing then, we talked a little bit about biodiversity. There are certain threats. One of them is definitely conversion of habitat and not having enough habitat for biodiversity to thrive. There are a lot of predators out in these blueberry landscapes of Georgia, at least. However, they're fairly generalized and not preying specifically on SWD, but we still need them for other pests in the system. While there are parasitoids at this time, from our samples at least, they're kind of more rare, but they are very diverse, so that's encouraging. And I look forward to talking in the future about these habitat optimization demonstration plots that we're working on, and I hope to be invited back to share what those look like, opportunities within and around fields. And so thank you again for joining this virtual session with us. Sorry for the technical difficulties, and if there are any questions, I think Zach and I are hanging out here. So thank you.
Yeah, so thank you, Dr. Schmidt. Yeah, like you said, we're now going to be answering questions from the audience. Again, type your question in the questions box and press send. Also, as a reminder, if you are requesting pesticide credits from this presentation, don't forget to sign out of this presentation by going to the audience chat box and type your first name, last name, and the states for which you're requesting credits. And we'll take our first question if anyone has it. Okay, Doc, David Riley asked, do you know of negative impacts of pesticides?
So that's a really good question, Dr. Riley, down the hall from me. And the answer is yes. There are some of the research that's coming out now is not only testing for the importance of managing habitat, but also then how these management strategies can then align with our pesticide, the need for pesticides for given pests. And the answer is pesticides or insecticides in particular kill insects. So again, timing those to reduce any risk to that biodiversity is key. So that's kind of the basis. And there have been some experiments in Europe trying to do some of that calibration, and it's not all the way there yet from my understanding. We don't have that planned at the moment. Our first strategy is to kind of find some good habitat management protocols for the growers here and plants, and then move forward from there. Thank you for your question. Did I get it?
Give it another moment or so. If anybody has any questions, to type them in the question box. And
yeah, we're actually So that one wasn't exactly a question, but thank you, Kristen Woods. We're all actually quite interested in the birds. Another part of my program is I'm working with, I don't know if you know of Tall Timbers, but I'm working with Tall Timbers and their bobwhite and bobwhite conservation. And one thing they're interested in is, are there habitat management that they're doing for bobwhite conservation having an impact on the bobwhite in terms of like what diet they're having, and whether that diet then corresponds with success. And so we're monitoring, and this is funny, the people in my lab right now don't like it as well, because we're taking fecal samples from those bobwhite, and then we assess what kind of things they're eating and whether habitat management influenced what they're eating. So yeah, I'd be happy to talk about that sometime now. That's all sometime in the future, it's all being processed.
Okay, well, if that's it, that's just about all the time we have. I know we're a few minutes over, and we apologize for that. Thank you again, Dr. Schmidt, for your time and expertise. To all attendees, thank you for attending this presentation. Don't forget to sign out for pesticide credits in the audience chat box. All educational presentations in the virtual trade show will be available for you to access until April the 30th, 2021. So come back if you missed a presentation or just want to rewatch one, or if you need to search for a service or product provider in the virtual trade show. Again, thank you for your participation, and this concludes this presentation.